Well, here we are at the end of chapter 7. We've got just one more section on confidence intervals, this time for the standard deviation. Well, for this section, we're going to need a whole new critical value. It is called chi-squared. So take a look at this word right here. It looks like chai or chi, but it's pronounced chi. It rhymes with thigh or my chi-squared. So chi-squared comes from this little formula right here. It's basically degrees of freedom. This is the sample standard deviation, and this would be the population standard deviation if we know it. If we don't know it, we're going to need to use a table to look up critical values for this down here. So that means we're using this distribution, which is different than before. Notice that it starts at 0 and then proceeds. So there are no negative values because it's squared. It's also not symmetric. So when we look up we're going to have to look up left-hand critical values and right-hand critical values. So it's not symmetric, nothing's negative. We get to use a new table today, exciting. And of course, degrees of freedom is very easy, n-1. So let's do an example just using table A4. So here's table A4. The right half of the table is used to find the right critical values. The left half is for the left critical values. So what I do is I split my table in half, just put a line down the middle, and then when it says use 90% level of confidence, you would look at this, and 90% goes with the 10% because they add up to 100. Likewise, 95% on the left corresponds to 5% on the right. So I just go ahead and put these lines up here to help myself out. You can do the same. So we've got degrees of freedom, 31. And since the level of confidence is 95, then we've got alpha at alpha at 0.05. So we then need to cut that in half, so it's 0.025. So for some reason, I like to start with that, 0.025. Oh, I suppose because it's the easiest. This says 025, that says 025. All right, and we need degrees of freedom 31. So go down here, and you look over, there is no 31, so use what's closest, a 30. And if you go back to that column, that's going to be 46.979. And then if you connect that one to this one, it's 975. Go down to degrees of freedom as 30, and chi-squared left is 16.791. So that's pretty simple, straightforward. So how do we actually make the confidence interval? You may be thinking, oh, it's graphing calculator time. But no, sorry. The people at Texas Instruments did not put this formula in the calculator. I don't know. At the next meeting, I'll bring it up with them. So luckily, the formula is not too bad. It's just degrees of freedom, the sample standard deviation squared, and then you put the two critical values here. At the end, we'll need to take the square root. So notice that chi-squared left goes on the right, and chi-squared right goes on the left. It's really not that big a deal. When we do the numerical example, I'll show you why that's done. The last thing to do in order to get rid of this square here is take the square root of everything, and then we'll be done. So here's an example without a story. We've just got that S equals 9.4. The sample size is 42, and since it's 98% level of confidence, we're going to use alpha equals 0.02. So degrees of freedom is 41, and we need the table. Sorry, I've got to just plop this down right here in the middle. But let's find the critical values, and then I'll get rid of this chart. So alpha equals 0.02, so we need to cut that in half for each side. So that's going to be 0.01. Degrees of freedom, 41, they don't have, but they have 40. So we're going to use 40, which means on the right it's going to be 63.691. And then go up and over to 99, down to 22.164. So now we can get rid of that table. Okay, then to make the interval. So here's the setup, standard deviation squared, degrees of freedom. And now this is chi-squared left, and it goes on the right. This is chi-squared right, and it goes on the left. The reason is when you divide by a smaller number, you get a bigger result. So look at the next step. On the right, I divided by the smaller critical value. I got the bigger result on the right, which is the way that's supposed to go. Over here, I divided by the bigger number, and I got the smaller answer. Lastly, I just took square root of both sides to get this final answer. There's the confidence interval for standard deviation. Okay, now here's a way that you could actually use this. So I had a calculus class last semester. They did very well, averaged 80.4% on the first test with an S of 10.6. Usually you want the standard deviation to be 15 for exams if the exams are worth 100 points. So is it possible that it could be 15? So we're going to make a confidence interval based on the first sentence and then see, does 15 land in that interval or not? Is 15 even possible? So I like to write down the given information, what I need to use. Then here's table A4 again. So take this, cut it in half, it's going to be that 0.025. Degrees of freedom is going to be 38. Once again, just going to have to use what's closest. That's going to be a 40. So this is going to be a 59.32. And then if you go over here, the corresponding one, on the left is 24.433. Okay, we don't need that table anymore. Achoo! Just kidding. Excuse me, I sneezed. Next, set up the formula. We've got the sample standard deviation squared. We've got the left one on the right and the right one on the left. And then take the square root of both sides. And here's the final answer. So for that class, by the end of the semester, after they've taken all of their exams, then the standard deviation is somewhere between 8.37 and 13.044. So is 15% possible? My answer is no. And I'm 95% confident when I give that answer no. It does not seem possible. All right, until next time, see you in Chapter 8.